Thank you so much for the opportunity to talk about manufacturing policies, or as I like to call it, where's Bob the Builder when we need him in this ever-going struggle between people wanting stuff and people needing to make stuff. So your balance of making stuff is a pivot point between variety and volume. The higher your volume, the less variety there is going to be in the items that you're manufacturing. And the higher your variety, the less volume you're going to be making. So when we talk about this balance between variety and volume, traditionally we've broken it into 4 kinds of production. Engineer to order, which is highly customized. Make to order, which is less customized. Assemble to order, which is the put it together, do I have the parts? And then make to stock, which is I want it on the shelf all the time, every day. And if we look at some of the boxes across here, the ETO, the engineer to order, I'm going to have a lot of focus in my business around design and purchasing and manufacturing, whereas make to stock, I'm going to be assuming I have inbound inventory that's standardized. I'm going to be manufacturing a standard product, assembling a standard product, inventorying a standard product, and then shipping a standard product. So when we're trying to balance these 4 modes of production, we need to look at where do we master schedule? Where is our bottleneck, or where is our constraint in terms of the production points on these items? So if I'm looking at a make to order setup, I typically in make to order, I typically have a large number of raw materials that I can pick and choose from in my drive towards some kind of custom manufacturing. And I am going to master schedule as close to my end item as possible because I'm wanting to minimize my turnaround time. In a assemble to order environment, I'm going to have a large number of raw materials that can be assembled into a diverse number of finished goods item. You know, the business case here is computers that I can have, you know, 5 different hard drives, 5 different kinds of memory, 3 different kinds of monitors. And out of that, I can then configure a boatload of finished goods that are variable, that are unique. So in that environment, I am going to schedule and focus my master schedule at the gating point between the inventory and my desire for finished goods inventory. So this is I'm typically going to master schedule right around that customer order, or the configuration is going to be my master scheduling point. And then if I look at make to stock is where I typically have fewer raw materials and I make a whole lot of things. My go-to example for this is manufacturing wine, where I'm going to have, you know, 2 or 3 raw materials and I'm going to make a whole lot of different kinds of things. People talk about candy, where you've got, you know, sugar and flavorants, and you can make a whole boatload of stuff out of it. So here I'm going to have few raw materials, so I'm going to want to master schedule and forecast at this lowest level to make sure that I always have inventory available for this spring out of many different end items. So this gives me the tipping point between pull manufacturing and push manufacturing. And pull manufacturing is when I have an order, I am going to pull production to meet that order. So this pivot point, the decoupling point between forecast and real demand being customer orders, in a make to order or assemble to order environment, I'm going to be working more in a pull method and a push method. allows me to drive that decoupling mode straight to the warehouse. So my assumption is going to be that in make to stock or ship to stock, the customer order comes in and I'm going to push product straight out to the customer. It's not going to have to go through layers of production. So the more complex your item, the further back into production I have to reach in terms of balancing what am I going to forecast versus what's going to come in on a customer order. The goal is to have as much inventory as I need. Not too much, not too little. It's the Goldilocks thing, right? I want to have just the right amount of inventory to balance a reasonable delivery time to a customer versus having a pile of inventory in my warehouse. And for that, I'm going to start looking at my different strategies, my different manufacturing policies, as well as how do I set up those BOMs, routes, items to better manage that. So the make to stock environment, this is what I call an artist strategy, right? Do a whole lot of stuff and then you have it ready for sale. An artist isn't going to arrive at an art show with paper, paint, and brushes and saying, well, yeah, I can make you something. Come back, they're going to have the artwork ready displayed to be taken off the wall. So one of the assumptions we're going to have is my final bill of material is going to be designed around a sales model. So reasonably short lead times up at the top, that I can mass produce standard items and have them available. So the assumption is whatever inventory I have, that's fair game for sales. The sales bill of material is my finished product, and that is assembled as part of that flow. There's no modifications, there's very little standardization. You may have some revision control, but that's done in a programmed, systematic way. The sales order is only going to ask for that end item. It's not going to ask for an exploded bomb. It's not going to ask for something to be configured. The guys are going to, the customer is asking you that they want to buy a coffee cup. They want to buy a toy. It's a predefined, no options, no features item. And then for our sales bill of material, we're going to manage the finished product as an inventory item. We're not going to manage it as an in-process item or as something that is going to be turned into something else. So when we create the delivery, when we dispatch the customer order, this standard end item is either issued or backflushed from inventory. There's no modifications, no change there. And the only engineering assistance we're going to need is on this. You know, we've been selling the same can of soup for the last 3 years, and now we're going to change labeling and soup it up and make it fancy, right? So what do we do in terms of make to stock setup inside of the system? The first thing is that your lead time on that item from a sales point of view is going to be 0, potentially 1. Because that inventory should all be on the shelf. We are master scheduling, we are planning to always have inventory. So because I have it on the shelf, I should be able to ship it the same day or ship it overnight, right? The production and purchasing lead times are typically long. They could be unpredictable, and that's why I am bulk building inventory for these kinds of products, because I know it may take me months or weeks to make an item. I may be dealing with flaky vendors or a flaky supply chain. So when I make it, I make a whole lot. It may be items that are very difficult to set up. So when I make it twice a year. I don't make it every week. I don't make it every month. I make it seldom because the cost of production is so high. So I'm going to set up once, do a big run, and then fill up my shelves. Whatever is on the shelf is completed, it's tested, it's ready to be sold. There is no assumption of any further work needing to be done on that item to get it out the door. Available to promise and capable to promise is turned on for promising the end item to the customer, but it adds overhead to the system that's not needed. So if your model for this item is make to stock, the assumption should be you always have it in stock. So you should not have to be double checking that it is in stock. So this is something very often we'll say to customers, turn it off. There's no setup time on those orders, there's no runtime, there's no production. So I am master scheduling at that top level, maybe using safety stock, as much as I hate safety stock, as an extra stopgap to give me a little bit of buffer. But everything around that item is lean and mean. There's not a lot of fluff in the final assembly for that item when it's on the shelf. So from it being on the shelf to going to the customer, one step, nothing else is required. When we get to assemble to order, I got a bit more fluff here. I've got a couple more things that need to be done. And my working model is, think of a sandwich. That we roll into Subway and you got to make a bread choice, and then you make a cheese choice, and then you make a veggie choice, and then do you want oil and vinegar on that, and they wrap it up and they send it out to you. And the assumption is that all the inventory that you could possibly need is available all the time to assemble that item. So you have all of those components ready to go. You have inventory, we're not waiting on production, and we're going to pick a configuration of items. So your sales bill of material is a finished product which is assembled at the sales stage. They can appear as separate items on the sales order document, or it could be a configured item. So you could say, if we go back to our computer example, I want a 24-inch monitor, I want a 10 gig drive, I want a laptop. And those could be 3 separate line items on a sales order, or we could use the product configurator in D365 and take the customer through a pre-planned questionnaire that is going to give them the rules for assembling this order. So it could be that they can only have 1 hard drive, so the customer can't select 2 hard drives. And that gives you a better quality of product, and it gives some very clear paperwork or process flow in terms of what needs to be assembled at the very last minute to meet this customer requirement. My pinch point or my bottleneck items, we try to keep in stock at a minimum. These are the items that typically tend to be expensive or hard to get hold of, but if I don't have them, I can't make the sandwich. So think of cheese as being the thing that everybody wants cheese on their sandwich. So I always have to have minimum inventories of some of those bottleneck items. The components can also be sales and stock items in their own right. Think of selling spares or replacement parts. When you create the delivery to send out the customer order, these components we can either backflush or pick from inventory depending on how you have structured that and what the velocity of turnover of those items is. And again, very seldom am I going to need any engineering help. They've already figured out that these are the possible build combinations for assemble to order, that these things can be bolted together like a Lego set in a predefined way. So my setup in the system around assemble to order, a short sales lead time. We're going to need some runtime at that top level for putting this together. There may be a final test that, you know, if I take these 12 things and put them together, do they work in that collaboration, in that configuration? There's a better word, in that configuration. I'm going to have available to promise and capable to promise turned on for promising the end item to the customer as a validation that those components, the things that I'm going to assemble together, are in inventory. Typically no setup time, but we are going to have some kind of runtime for that final assembly / testing route. So assemble to order, the goal is quick turnaround. The goal is standard products being assembled in a variety of ways that is a standard output. And these have been predefined, and typically we're going to use Product Configurator to do that for us. So let's go down one more level of complication. So if we're going to look at a make to order versus engineer to order, in a make to order, before the sale is signed off, product development are probably noodling on something. The customer comes in saying, hey, I want a quote. We send them a quote. The customer looks at it and goes, oh, okay, fine, let's have an order. And the sales process ends, production and logistics kicks off, and then we do a delivery. So the make to order is typically using standard components or a standard recipe. There may be a little bit of variety in it, but not a whole lot. And there's a whole lot of can we make it? Yes, we can, involved in make to order. The goal for make to order is I never have inventory. I never have end item inventory, because I never quite know exactly what configuration a customer is going to want. In an engineer to order environment, this pre-sale cycle takes a lot longer because there's much more noodling between sales and the customer. This is typically something that is customer specific. It's engineering are heavily involved in this. It's something we've never made before, that there's design work, there's testing work before we even get into production. Once we get into production, it goes fast, and then we can deliver out to the customer. The customer is involved from sales through engineering, through production, through delivery. It's typically a much more hands-on environment with the customer. So we need to be able to involve those touch points throughout the cycle, as well as managing the inventory. So our make to order is my beloved Bob the Builder. Can we make it? Yes, we can. And the customer knows that this is not off the shelf. It is not make to stock. It is not assemble to order. They are going to have to wait while we do a custom, semi-custom job for them. We're only going to manufacture this product when the customer gives us an order. So the customer can't expect it to come off the shelf, right? We're waiting for their order because they're going to have some specifications around that item. The good thing for us is a make-to-order environment means that we never carry finished goods. We may carry some sub-assemblies, and then we may manufacture some components from scratch. So we have a level of complexity that's deeper than assemble to order, but I never have the end item on hand. The number of variables is too great. I can never actually figure this out in advance. The production bill of materials is my finished product, typically deep and wide. We could have many levels in this bill of material. The components in this bill of material are typically physical items or labor to create this make-to-order product. Very often there is some emergency engineering help going to be needed. and the customer knows that because this is being semi-custom made, there's some extra noodling required around it. There may be some other requirements around customer sign-off on that sales order as well, in terms of product validation or engineering specifications. For make to order is where we most commonly use from a forecasting point of view. We're going to use some kind of forecasting, our planning bill of material that we're going to say, let's say I make to order. What am I going to make? I am going to make wheelbarrows, and they come in different colors, they come in different sizes. So I can forecast that I know that I'm going to make 1,000 wheelbarrows this month, and of that, 40% of them are going to be red, and 20% of them are going to be green, and the others are going to be a mix of color. And I could also know that 80% of them are big and 20% of them are small. So I can take my forecast and structure it that way so that when I'm buying product and I'm making some items, I have a fighting chance of having most, if not all, of the raw materials and or sub-assemblies on hand, so that I can do this as a make to order. So quite a lot of planning bills are used in make to order setup based on my sales history, based on my experience, based on my market knowledge. My lead times are going to be longer because now I do need production lead time, and I need some of that sales lead time where the customer's noodling backwards and forwards. I may need some extra dispatch lead time as well. When I make it, there is typically a short run time at the very top level, but there could be a long lead time at my levels 2 and below. Just kind of depends on what I'm making. The run and queue times I'm going to be needed because this is now going through more traditional production processes, because I am making this to a customer order requirements. We will use queue and setup times, and I am going to have run times for route processing. So this is more of think of it as a more traditional, that the customer order comes in the top, and I now know I need to make 10 big green ones, and we kick it into gear and off we go. The day before, I really wouldn't have known exactly how many wheelbarrows I needed. So I can't make them in advance. It's only when the customer order comes in that I can actually start that production, as opposed to grabbing parts off the shelf and making it, right? Engineer to order, sorry. Engineer to order is when customer comes in and says, you guys build bagging equipment, and I want something like you've built for this person, but I need it bigger, wider, faster. I have all of these extra requirements. So can I please sit down with your engineering crew, and we are going to design and engineer an item specific for me. So my lead time is very long because I need purchasing lead time for customer specified items. They may say, I can't use the motor you normally use, I need a bigger motor. So I've got to go out and find what that motor is, engineer it into the product, purchase it, wait for it, get it in, test it, make sure that's all going to work. So my purchasing lead times, my production lead times, and then the sales lead time are long on your engineer to order. We always try and have some kind of forecast for our most commonly used components, so that I can have a stab at being able to kit out for production on demand. It's hard. Again, I'm going to use an allocation forecast, that planning bill, that I'm going to update with trends and market knowledge. But there are always items that we are going to need that we've never needed before, based on customer specifications or what the engineered product demands. I am going to need fully defined bills of materials, and I'm going to have them routed. I'm going to have them set up in terms of capacity management, and that is the hardest part of engineer to order. We have many customers that they start building things out of sequence just because the engineers have finished that part of the design. And if we looked at the structured bill of material, it's like, whoa, this is kind of crazy land. So the control, the management, the visibility of ETO type production is much more complicated, and you become a lot more dependent on tools inside of D365, like the configurator, like project management, like capacity planning and resource scheduling, material visibility, etc., to be able to keep your arms around what for some customers are huge projects with hundreds if not thousands of line items. You're available to promise and capable to promise could be vaguely good. I've never had a whole lot of success around a whole lot of this stuff. If it's a really heavy engineering environment, like going from scratch engineering environment. If your business model is we make a certain type of, let's say, equipment, I make vegetable bags, then you have a better than fighting chance of having some visibility into what raw materials you could need, as well as what the availability of stuff is like. And you're going to have some other bills of materials that you can copy and steal from. You'll probably have some other engineering drawings that we can take, run them through ECM, the new module inside of D365, so I can get my arms around it and have bills of materials that I can then bring into the system. We're going to need setup and queue time to fully validate that route for processing. Any questions at this moment in time? There we go. I think I have one.
You sure do, Anne. Question here. For the setup, how well does this work for formulated items instead of bombs, or a mix of bombs and formulas?
Yeah, have at it. It really doesn't matter a whole lot if it's bombs only in terms of discrete manufacturing or formulas. The two tend to cohabit the same space. There are some fundamental differences in how they're executed, but if for some part of a product it makes more sense to use a formula than to use your traditional discrete bill of material, have at it. At the end of the day, the system doesn't really care how you made the item, it's just that you made the item. So so long as we can mix and match in an organized fashion, that the end item or the component item, that is product A is made with a formula, product B is made with your discrete bomb, and product C is putting A and B together, not a problem. Any other questions? Great, thanks, Joseph. All right, let's have a quick touch on lean, because everybody really, big goal, let's go lean. Second goal, let's not go lean, right? So when we're looking at these different kinds of manufacturing modes, of different ways of pushing product through a production environment, whether it's project or job shop or batch or repetitive, there is a question always around, how can I do it more efficiently? And people turn to lean. And the lean has 5 F's, right? It's the finish it. If you touch it, you have to finish it. And in an engineered environment, that simply doesn't work. We're going to flow one piece at a time. So when I make something, I don't make 10, I make one. And in a make to order or assemble to order environment, very often that doesn't work. I'm going to flow in one direction, and that typically works across all our modes of manufacturing. Faults, never pass on a defective piece. This is really hard in make to order and engineer to order environments, where we know that we could have things that are going to involve engineering or rework because they just don't fit together as well as the drawing said they would. And you may have to pass on a defective piece and allow other people to work on it, and then it'll come back into the main production flow, and that's going to violate one of our lean rules. And then following, balancing each task to a tack time or a run rate, that's pretty much good manufacturing mandates for all of us. So if you have a lean mandate inside of your business, you may have to balance the world of lean versus the world of reality, and sacrifice, if that's the word, some of your lean mandates in terms of keeping production moving. So the summary of the modes, if we think about, you know, what kind of a business do you have? If you regard your business as being a project kind of business, your volume of products is going to be low, your variety is going to be high, and we call that engineer to order, versus a continuous flow kind of a business where we're more into the make to stock environment. Always remember your decoupling points with your engineer to order. Your customer's impact on your production is going to go all the way back down to raw materials, where they may be specifying a specific vendor, never mind a specific product. But in make to stock, the customer doesn't care. They just want whatever you have on the shelf. There is no deviation to that. So as we go down these different production types, we're constantly balancing the needs of the customer for a customized product versus the balance through production of new and different products, and potentially right down to a specific supplier raw material. This is my little cheat sheet slide, where I'm trying to draw out, you know, what's happening with raw material, so, and what's happening with finished goods. So make to stock, I have it all. And if I need to make stuff, I have it and I can get that turned around. Engineering's not involved, customer can get it, you know, really lickety split. And as I go further down, as I get into more and more complex methods of manufacturing, at engineer to order, I don't have any finished goods because I'm making it from scratch. I don't have sub-assemblies because I don't know what they're going to be. There's probably going to be raw materials that I don't even know about, never mind having on hand. Lots of engineering type. And then if I have some kind of an existing route I can work off of, I can try and make a delivery promise based on capacity and when I think material's coming in.